how are you? My name is Anna Tenbensel. Welcome back to my channel where I'll huff and puff and blow your house down. I'm only making a couple more videos like this because I still have a couple solutions that I've done while I was away traveling. So here we are jumping back into these LeetCode solutions, and this is number 70, climbing stairs. You guys are more than welcome to read this question on your own time, but essentially we're trying to find the distinct ways to climb a staircase when climbing either one or two steps at a time. So that is this. I want to show you my submission because I did not love it. It got less than 50% on each, and I chose a dynamic programming solution for this. But if I'm being honest with you, I was thinking as for a solution using like an nth Fibonacci step sequence sort of thing, and I think I should have done that. So again, another video, another time. So let's go ahead and go through this solution for number 70, which again, the solution is in Python. So I started off with my base case that if n is less than or equal to 2, then we just return n. And I'm using that as my example because if you look at the examples over here, n is equal to 2, there's only two ways you can climb. And it would be the same way if there was just 1 or 0. Like there would only be one solution for these things. So starting with that base case, then I said if n is 1 or 2, there are n distinct ways to climb to the top. So for this example, we have dp1 and dp2, which are set to 1 and 2. We then enter this quick little loop that starting from step 3 up to step n, which is where this dynamic programming comes into play. For each step I, it calculates the number of distinct ways to reach the top. So the number of ways to reach step I is equal to the sum of the number of ways to reach the previous two steps, which in this case would be I minus 1 and I minus 2, because you can either climb 1 or 2 steps at a time. So we then we store that result in DPI, and like in the DPI entry array, and that will continue until it's calculated the number of distinct ways to reach all n steps. So when we return dpn, it contains the number of distinct ways to climb the top of the staircase in n steps. So this way with this dynamic programming for me was just a way that we didn't recompute values of the same steps and kind of improve the efficiency. So that was my solution that I was kind of going with at the time, but obviously 2020 hindsight, I think I could have done something with a little Fibonacci something or other. So that is the solution, and you guys please do something with this because I would love to see something better that gets over at least 50% on each of these. So I will leave this code in my GitHub repo, which is linked down below, and you guys are more than welcome to fork and clone, make it better, make it worse, have some fun, learn something new, and I will see you guys in the next video. Thank you so much for watching. Goodbye.